All right, so in this first video, we're going to take a look at a very brief introduction to what chemistry is, as well as the process that we use to study chemistry, which is the general process we use to study science overall, which is called the scientific method. So first of all, let's talk about what chemistry actually is. And we've heard of chemistry before, I'm fairly certain. What it is, it's a systematic study of the properties of matter. So when we talk about properties, really what we are referring to here are characteristics. Properties are just another name for characteristics. So that'll be things like their physical characteristics, physical properties, and then also their chemical characteristics and chemical properties. And that's really the main focus of chemistry: chemical properties, chemical characteristics of matter. The changes that matter undergoes, and again, the changes that matter undergoes, we can trace that all the way back to the chemical properties, chemical changes. And then what often gets overlooked is as matter undergoes changes, there are typically energy changes that are associated with those. And in our class, we will take a look at some of those energy changes a little bit later on in the semester. If you go on to General Chemistry 2, you'll focus a little bit more on that and do a lot more calculations involving energies. So we define chemistry as the systematic study of the properties of matter. So what exactly is matter to begin with? And we can define matter in a non-technical way as simply the stuff of the universe. Okay, and stuff is in quotations. And what exactly is the stuff? Well, stuff we can think of as anything that has mass. We can measure the mass of that thing and occupies some space or volume. Okay, and that is what we define as matter. So, for example, let's say a pen would be an example of matter. It has mass. We can measure the mass. We can measure the volume of a pen. The chair that you're sitting on. These are sort of fairly big things, but also even small things. So, for example, the air that you're breathing in right now is composed of different gases, such as oxygen, nitrogen, and lots of other ones. These would be examples of matter as well. So we study the properties of these gases like oxygen and nitrogen. Really what we're doing there is we are doing chemistry. And chemistry is something all around us. We don't necessarily think about it, every day, but we really can't live without chemistry. And essentially chemicals. And often when we hear the term chemicals, we normally think there's typically a negative connotation associated with the word chemicals. But really what chemicals are nothing more than substances. Okay. And substances that have a fixed composition. Okay. And by that token, okay, matter would be example of being composed of different types of chemicals. So similarly, something like water, even though we don't necessarily think of it as a quote unquote chemical, it is a substance that has a fixed composition, right? You may recall or you may know that water has a chemical formula, H2O. So two hydrogens and one oxygen combine, and that's the fixed composition of water. And it's a chemical as a result of that. We have chemicals in a whole host of things. So for example, in your toothpaste, okay, there are several chemicals that we rely on. So for instance, there's fluoride in most toothpaste that help protect your teeth. There's all sorts of gritty substances that help remove plaque from the surface of your teeth. So things, for example, like maybe calcium carbonate a little bit in there. Okay, which is really nothing more than chalk, and a bunch of other things. You look on the ingredient list on your toothpaste tube, you'll see lots of different things, lots of different chemicals that are in it. So chemistry is all around us. It's also in us, right? So all the chemical changes that are happening inside of you right now, we rely on those to produce energy that you use to do a whole host of things, like to study, to sleep, to walk, etc. Chemistry is at the heart of all of those processes, so much so that we often refer to chemistry as the central science. It is important, probably the most important science relative to all the other ones. So when we study chemistry and we study science, we do it systematically, we do it logically by a process known as the scientific method. Okay, and the scientific method is a logical way systematic way to understand, to try to understand the way around us or the world around us. Okay, and you probably use the scientific method in a fairly regular basis, but maybe you don't necessarily refer to it as a scientific method. But it is when you have a problem, for example, your car doesn't start, and you try to figure out why is it not starting, and you go through all the different options of reasons why. You're actually employing the scientific method, and we'll talk a little bit about what that method is here in a second. Your book does a good job of highlighting some specific examples in the past, but we'll talk about some simple examples. So when we talk about the scientific method, it all really starts with making observations and then formulating a question as a result of those observations. So for example, observations are things that that you see, or in a general sense that you observe, and seeing is observing. You see or hear, etc. And then based on those observations, we can develop a question. So for example, you observe that, let's say in your house, you have a plant near the window grows better. So it's a healthier plant, for example, than the same plant that's in the inside of the house or away from the window. So then the plant away from the window. So that's an observation, right? You see that, you observe that. And then we can formulate a question to try to think about now, well, how can we understand what's happening? So a question could be, so why then? Why does the plant near the window grow better? So based on those observation or that observation and the question, we can then come up with a hypothesis. And the hypothesis really is nothing more than a testable, tentative explanation for those observations. Okay, so for example, a possible explanation for that observation would be plants need sunlight to grow best. Now, that's a fairly straightforward hypothesis. Can we test it? Actually, we can. And the key thing here is that the explanation that you propose needs to be one that you can test. And we can test these hypotheses using what are known as experiments, right? So experiments then are going to be the test. Testing the hypothesis. Okay, and in this case, our experiment could be a very simple one. Okay, we can grow two identical plants. Okay, we keep everything constant, same amount of water and soil. And the only thing we're going to change is their location. So we're going to change their location. So one is going to be by the window. So, or one plant in the sun, and then the other in the dark. Okay, and then we just make some measurements and to see how those plants actually grow. And then we can gather our data, those numbers that we collect, height of the plant, whether it grows thicker or thinner, whether it's droopy, whether it produces fruit, etc. And then based on the data that we gather, we can then draw some conclusions about that data, right? And obviously here we can determine that, yes, indeed, sunlight is necessary for the proper growth of plants. And then as a result, these conclusions then will allow us to confirm the hypothesis, or we can prove it to be false. And if it's proven to be false, well, then we can repeat this process over and over and over again, and we can come up with a new hypothesis and go through this cycle until we gather a bunch more data, until we actually come up with a whole host of explanations and data points to explain or to try to explain this particular observation. And that, in a nutshell, is what the scientific process actually is, right? And we've employed it here to just try to explain the growth of plants. Now, after we've gone through and we have collected a bunch of data and done a bunch of experiments, we may develop what are known as scientific laws or scientific theories. And we'll take a look at both of these in turn, because they kind of sound the same and often people use them interchangeably, but they're actually not. So we'll take a look at a scientific law first. So scientific law is typically a brief statement that summarizes the relationship or the behavior of a system. Okay, oftentimes, these scientific laws are formulas. So, for example, what we can do is take a look at a law that we'll see later on in the semester, but it's a very simple law. And often scientific laws are named after people who came up or who developed, realized the relationship or the behavior of a system. So for example, when it comes to gases, there's a law called Boyle's law. And what this law says is that if the pressure of a gas is increased, the volume of the gas decreases. Okay, and this is a relationship that is seen all the time. Um, so it's a summary of the relationship, in this case, between pressure and volume of a gas. And Boyle's law is often written as a formula as follows. So the pressure, which is abbreviated P, and volume, abbreviated V. If we multiply the pressure times the volume, we always end up with a constant value. So P times V equals a constant. That is an example of a scientific law. In this case, it's one of the gas laws. And we'll see several of these gas laws later on in the semester. The other term to know here is scientific theory. And often lay people, people outside of science and generally use the term theory, and they throw the word theory around sort of willy-nilly. In science, a theory is not just a theory. Okay, when when we use the word theory in normal everyday sense, really what we are referring to is a hypothesis, right? So for example, somebody may have a theory, you're talking to your friends, I have a theory why my car didn't start. Okay, that's not a scientific theory. That you actually, what you're meaning to say there is, I have a hypothesis why my car didn't start this morning. With the example we looked at before, somebody may say, I have a theory why the plant by the window grows better than the plant inside. Well, technically, that's not a theory. That is a hypothesis that you're referring to. A scientific theory is much more powerful than a hypothesis. Okay, a scientific theory is a set of explanations or a detailed explanation for a physical phenomenon rooted in lots of hypotheses, experimentation, etc. Okay, so you have to actually, when you're studying something and you hypothesize, you do several experiments and you gather a bunch of data and you draw your conclusions, eventually you get so much information that you can develop a scientific theory, okay, which is now an explanation for whatever it is that you're studying. And a good example, one example of this would be, for instance, the theory of, we're gonna go on a much broader scale, the theory of plate tectonics. Okay, and if you're if you're a fan of geology, you know, how the Earth operates, for example, the theory of plate tectonics is an explanation, for example, why earthquakes happen and why volcanoes form, for instance. And it goes into a whole explanation as to, you know, how the surface of the planet is made up of these plates that are constantly running into each other, and as they run into each other, they cause earthquakes and volcanoes and all sorts of stuff. All that information, that theory is based on lots and lots of observations, lots of experimentation, lots of hypotheses, etc. Okay, so the theory of plate tectonics, that is not just a theory, that actually is an explanation that we rely on heavily to talk about, for example, you know, earthquakes, for example, that happened recently in Oklahoma, earthquakes on the West Coast, earthquakes in, you know, over in Japan and other places, and volcanism as well. So scientific laws, just a brief statement that summarizes the relationships or the behavior of a system. They're often formulas. Scientific theories or detailed explanations for physical phenomenon rooted in lots of observations, hypotheses, and experiments.